Hi, so the purpose of this video is to show you how you can use Excel as your time value of money calculator. Now, I won't go into really specific functions and entering all the different inputs, but really just want to give you a brief overview of how you can quickly and efficiently use Excel to solve time value of money problems. So with our traditional calculator, financial calculator, we have our five keys here that we use to approach various present value or future value of other types of time value problems. We also have our cash flow register that we can use for mixed streams. So you can do all these same problems in Excel just as efficiently, if not more efficiently, in some cases. So with Excel, we've got again a number of different functions that we can use to solve the same types of problems as we would on a calculator. So PV for present value, we've got FV for future value, and these can be for either lump sums or annuities. We have PMT for payment, we have NPER for number of periods, and we have a rate for the interest rate, you have effect for the effective annual rate, and we have NPV for present value of a mixed stream. So there are other certainly functions that we can use or will use in financial problems, but these are some of the most common ones for time value of money. And when we're in Excel and we want to start entering a formula for a problem, let's say it's a future value problem, we can, within any cell, we can start a formula, as always with the equal sign, and type in the shortcut. So if we know that FV is for future value, we just type in FV and click on the applicable function. And we can begin manually entering the figures here for the problem. Now this is a little bit more difficult to do it in this manner just because it's obviously a much smaller space. It's easier to make typographical errors or make some numbers swapped around in the wrong places. So the easiest way to do it is just to simply use the formula builder, and that is the FX icon up here. So this is the insert function shortcut, and if I click on that, it's going to bring up the formula builder over here on the right. So this will be a much easier way to enter the figures, and it will seem or feel much more like a financial calculator if you've been used to using that for problems in the past. So again, if we are looking in this case for future value, we have it here listed already as in the most recently used list, but if we wanted to search for it, if it wasn't in the list already, we could just simply type in FV at the top here, and it will come up in the list of matching items, and we can either double click it to begin, or we can just click on insert function down below, and now we can enter our applicable five key figures. And most problems you're not going to use all five boxes anyway, just like on a calculator, but they're all here very easily to navigate and input or create the formula that you need. So if we were going to do a future value problem, just as an example, which we already have typed in as our beginning of our formula, enter a rate in Excel, one big difference is that you enter the rate as a decimal. So if our rate is 6%, we type in 0.06, whereas on a calculator, you probably know that you enter it as a whole number. So a 6% rate on a calculator is going to be 6 IY. Okay, but again, in Excel we use that as a decimal. I'm just going to delete the other cell reference there. Put it up here as well. And from there we could finish off the problem. So if we had a 3-year period that we were looking to invest a present value of $1,000, I'll enter it as a negative sign. Alright, enter it as a negative number. That's really all we need to solve this problem. So the future value of $1,000 put into an account up front for 3 years at a 6% annual rate would give us a future value of $1,191.02. So again, very easy to use and navigate in this formula builder process. And if we don't want to look at some other types of problems as well, very easy to input those. Just simply select a new cell, click on our insert formula builder function there, and then we can use that to solve other problems. So a couple that I'll point out in the list here. So effect, just as an example for the effective annual rate of a nominal or quoted interest rate. So if we are, instead of a annual rate, we are compounding more frequently than annually in a future value of money, future value problem, for example. And so we're calculating a future value problem, and instead of annual compounding, it's more frequent. Let's say it's quarterly. We want to know what that effective annual rate is of the nominally quoted rate. We can use the effect function and very quickly determine what the effective annual rate is. So if our nominal rate annually is 6%, 0.06, and let's say we are going to compound quarterly, so the number of periods per year is 4, then that would give us an effective annual rate of 6.14%. So as we would expect, it's greater than 6% since there's more frequent compounding than just annual compounding. And then the last one I'll show is for present value of a mixed stream. So recall that in a financial calculator, we would use the cash flow register to enter mixed streams. So cash flow at time 0 would be the upfront cost of a capital budgeting project. Or if there's no upfront cost, if it's really just a present value of a mixed stream problem, we would just start with the first cash flow and just keep entering cash flows and frequencies until we have all of our cash flows entered. Now in Excel, you can do the same exact problem with the NPV function. So if we search for NPV, okay, and we would have our interest rate that we would enter here, again as a decimal, and just simply enter all the different values that apply to the mixed stream. So if we had value 1 of $100 and value 2 of 200, value 3 of 300, 4 of 400, and the fifth mixed stream cash flow of 500, and that would just click done, and now we've got a present value of $1,500. So the present value of these 5 mixed stream cash flows at a rate of 6%, make sure that was included, gives us a present value of $1,214.69. So note that even though the function is NPV, it's calculating a present value. So if there was in fact an upfront cost, let's say the cost of this project, this piece of equipment, or this mixed stream was going to be $500, we would then have to back the $500 out of this present value calculation to figure out what the net present value is. So a big distinction there to make sure you understand that the formula builder is building an NPV or net present value, but it's really calculating a present value of the cash flows. You need to deduct the $500 cost. So if it's a $500 upfront cost, we would then need to deduct that, subtract it for our net present value. This should actually be a positive, and that would be our true net present value. And a couple of other things I'll show you really quick are just some shortcuts that you can use within the formula builder. So if we are, let's say we're working on a future value problem, and let's say we work the problem first with a rate of 6%, and number of periods is 3 years, annual compounding, and we start out with $1,000. So basically what we're trying to figure out is what is the future value of $1,000 put in an account up front for 3 years at a 6% annual rate. And we click done, we see that the amount is $1,191.02. So let's say we want to rework the problem and see what the difference is for a more frequent compounding interest rate, or more frequently compounded interest rate. So one thing that we could do is just simply delete the 6%. Just copy it down here. A couple of different times there, so we can look at a couple of different options. So we have our original problem here, which is again an annual rate of 6%, but let's say we want to compound semi-annual. So we could simply just do the math in our head, of course, not hard, to just change this 0.06 to a 0.03, since that would be semi-annual compounding. Or the other option is just like you may write out in your notes when you're setting up the figures that you're going to need to input in Excel or a calculator. You could just go divided by 2. So this obviously is going to give you the same thing, and it even changes it up here to 0.03. So it's just a way that you can take more meticulous notes of a problem and see how recognize quickly how it is semi-annual compounding, because up here in the formula bar, when you have the particular cell highlighted, you can see that it's a 6% rate divided by 2, so that you are working with a semi-annual rate. Then likewise, it's 3 years annual, or technically 6 years is the number of periods if we are doing semi-annual compounding. So you could just put star 2 for number of periods, and then you'll see how it changes it to 6. So it's just essentially just doing the basic math for you. So if you want to do this way to kind of match notes that you may write out before entering them into whether it's the calculator or Excel. So just kind of a cool thing that you can do in Excel to kind of keep consistency with problems that are similar. Obviously there will be some problems where you have to calculate the same figures with different types of compounding. So you'll calculate it with annual compounding, and then you'll do semi-annual and quarterly. This is a way that you can kind of keep them all straight, and then you see what the differences are with obviously your answers separated out below. And we do the same thing with quarterly compounding, so just do divide 4 for quarterly compounding, and you see it changes the quarter to a quarterly rate of 0.015. So instead of you having to do it in your head or do the quick math in a basic calculator first and then input the 0.015, you just let Excel do the work for you. And again, quarterly, so that's 4 compounds in a year. There's 3 years, so it would be 12 would be the number of periods. Once again, not hard to calculate in your head, but just to keep it consistent and be able to view the details of what you did later on, you could just say times 4, so star 4, and let Excel do the math for you. Click hit done there. And so you've got the different answers for various compounding methods used for one particular problem. Annual, semi-annual, quarterly. And another thing you can do too is if you do have figures that are already loaded into Excel for whatever reason, if you want to write them out here, so if you want to have a present value of let's say $1,000, and you have an N of 3, and you have an I of 0.06. So if you're building templates for future use and you have them already kind of mapped out in Excel this way, then you can use cell references just like you can in other formulas. So if you're going to find the future value of this problem here, so let's say we're going to compute future value, and once you're in the formula builder, you can just use cell references. So the rate, so for rate, I just reference the 0.06 out here, so that's cell L9. And for number of periods, click in the box here, and then reference the cell over here, L8. And for present value, do the same thing, reference the cell out here, and click done, and then you can see I have the same answer. So again, just a couple of extra cool features that you can utilize in the formula builder, so you can kind of customize your Excel sheet the way that you want to for future use, and particularly for exams if you'd like.